Hello and welcome friends. Up till now we have discussed the method of finding the logarithm of a number. Now we are going to discuss the anti-logarithm, right? So we have discussed logarithm, and you would also recall that I had told you how logarithm and anti-logarithm are related to each other. Just to help you recall how they are related, let me give you this particular figure which I had discussed on the very first day in the very first session on logarithms. Now see, a number is converted to its logarithm. Now if you want to get the original number back from the logarithm, what do? You will have to go for an anti-logarithm. So you will find out the anti-logarithm of this value and you will get the number. I'm repeating, the number using the logarithm table is converted to the log value, right? It is converted to its equivalent logarithm. Now if you want to get this number back from this logarithm value, what you'll have to do is you'll have to reverse the operation. And how do you reverse the operation? You'll have to use anti-logarithm, opposite of logarithm. So once you have converted the number into its log and then you have gone for the opposite of logarithm, so the original number would be obtained again. So this is what you do. So basically the number gets converted to logarithm, and if from the number you have converted to logarithm and now you want to find out the actual number, because now suppose you only have this value, then you will have to apply anti-logarithms. Is this fine? So this is how logarithms and anti-logarithms are connected. And now let us discuss how to find out the anti-logarithm. Fine. Now I'm giving you the same example which I had used earlier. If you recall in the first slide which I just showed, this was the example: log 10 base, now this is called the base, it is written in the subscript, 1000 is equal to 3. So basically this is the, what is this? This is the log value. So of which number? This number. So this was the original number and the log value was log 10 base 1000. The log value came out to be 3. Now if I want to find out, please understand, this is the log value, this is not the original number, this is the original number. This is the original number. If I want to find out the log value, what would I do? I have already found out the log value. If I want to find out the original number from the log value, which is 3, what would I do? Think for a while. So what are you going to do? Basically you will have to use anti-logarithm and you will have to find the anti-logarithm of 3 and you will get the original number. Now this was the original number, right? So this is why you require anti-logarithms, because once you have converted a number into logarithm value, then again you might want to convert the values back to the original number, and for this kind of a conversion you would want an anti-logarithm table and to perform this anti-logarithm operation, right? What is the process? Again, you'll have to remember the process. Once you remember the process, understand the process, it's really a cakewalk. It's not a very difficult thing to do. So the first thing is, the log value that you have to write the mantissa. I hope you recall from our earlier discussions what is mantissa and what is characteristic. You basically have to do what? You have to write the mantissa and the characteristic separately. So you should be able to identify which part is the characteristic. You understand that the characteristic can be positive or negative. It would be before the decimal and the mantissa is after the decimal, right? So you have to separate them for your understanding, right? Now just to find out how much you remember from our earlier discussions, can you tell me, in this particular case, this is the log value of 1003, can you tell me which part is the characteristic and where is the mantissa? Everything before the decimal is characteristic, and 3 means 3 is same as 3.00. So basically this portion before the decimal is the characteristic and the mantissa is 00. You understand my point? So this is what you'll have to separately identify in the log value given to you. Which part is the characteristic, which part is the mantissa, right? Once you have done that, now first of all, the first thing that you'll have to do is you'll have to find the mantissa. You have to use the mantissa to obtain the antilog value from the antilog table. So then you have your mantissa in front of you and you will go to the antilog table to find out the antilog value. Is this fine? Right? We'll do some examples to make you understand this better. Once you have done this, now we'll have to work on the characteristic. So whatever is the characteristic, you'll have to add 1 to the characteristic value. Let's say the value of characteristic is C. So when you add 1, it will become C plus 1. That is why I've mentioned this particular portion here, right? So this is characteristic value C plus 1. So you have to add 1 to the characteristic value. Why are we doing this? We are going to make use of this in the next step. If the characteristic is positive, now please remember this. If the characteristic is positive, means plus 3, plus 2, plus 1, even 0. Then you can go for what? You can use this particular method. Here you will have to do what? Insert decimal after C plus 1 digits from the left. So now what was C plus 1? C was the value of characteristic. You add 1 to the characteristic value, so you'll get C plus 1. And if the characteristic is positive, then insert decimal after C plus 1 digits. So you count from the left and then you insert decimal after C plus 1 digits. Then you will have to put in a decimal, and this will give you the original number that you were looking for, right? However, if the characteristic is a negative, again you have to find out C plus 1. However, you have to this time insert C plus 1 zeros between decimal and first non-zero digit after decimal. So basically you will have to first of all find out the value of C plus 1. Then whatever is the value of C plus 1, you will have to put in these many zeros between the decimal and the first non-zero digit after the decimal. So you'll have to basically put in these many number of zeros. Now, is this making sense to you? Is this understood? You don't need to cram this while doing it. Just try and understand this. When you start doing number of questions and you have practiced on 20-25 questions, then you would be able to retain it. So you just don't need to cram it, just understand it at this point of time. Now please understand there's one difference here. What do we mean by this C plus 1? Then I have put in this kind of a sign here. See, this kind of a sign is there, and within this sign I have mentioned C plus 1. This is basically mod. This is not mode, which we have studied in statistics. This is mod. Mod basically means whatever the value is inside, the result outside would be positive only. You understand my point? I'll make you understand why I've mentioned this mod here, right? Let's say if the characteristic was minus 5, so it is negative. I'm just giving an example. So C plus 1 would be minus 5 plus 1 is equal to how much? Minus 4. Remember this calculation, because now we are adding basically a negative integer to a positive integer, so you know the rules. So minus 5 plus 1 becomes minus 4. So how many zeros are you going to insert? Minus 4. There is nothing like minus 4 zeros. You cannot insert minus 4 zeros. You can have 2 breads. You cannot have minus 2 breads. You can have 3 pencils. You cannot have minus 3 pencils, right? So that is why I've put in this mod here. What would this mean? If the characteristic is minus 5, insert C plus 1 becomes minus 5 plus 1, and then there is a mod sign outside. What does this mean? This basically means minus 5 plus 1 is minus 4, and then I told you whatever comes out of this mod sign is always positive. A positive number inside would remain a positive number outside. A negative number inside, like this one, would also convert into a positive number. So this would become plus 4. So plus 4 zeros you are going to insert in this particular example that I have taken up. So you have to basically insert plus 4 0 between the decimal. So you will insert like this, plus 4 zeros means 4 zeros between the decimal, and from here you would start your first non-zero digit which you have obtained from the mantissa. So let's say mantissa you obtained 2, 3, 4, 5. So you will mention it here, right? So basically, I'm sorry for this, Basically this is going to tell you how many zeros would be there between the decimal and the first non-zero digit. Is this fine? In both the cases what you have to do is add 1 to the characteristic value. If it is positive, insert decimal after c plus 1 number of digits. If it is negative, insert after mod c plus 1, insert mod c plus 1 number of zeros between the decimal and the first non-zero digit after decimal. Now you might be finding it a little difficult to follow. We have used technical terminology, so let us have a look at some examples. Right now this is the anti-logarithm table, slightly different from the logarithm table, otherwise it is same. You see that there also we used to have these kind of values, and there also we used to have these mean differences, and 0 to 9, these columns were there. However, you would find that logarithm table starts at, it does not start at 0.00, it starts at a different number. On the other hand, anti-logarithm table starts with a 0.00. This is the main difference here, right? However, the method of using the anti-logarithm table would be the same, right? Since you already have an understanding, I'll be a little quick while discussing these examples. Now, anti-log of 5.4449. Step 1 was you break this into the characteristic. Now this one is the characteristic value and this is the mantissa, right? Step 2 was from the mantissa, using the mantissa find out the anti-log value from the anti-log table. So the methodology, you remember, what was the methodology, do you remember? We break it into different segments, first 2 digits in one segment, then the third digit, and then the fourth digit. You have to look for 4 in the 0.44 row. So 0.44 row is this one. And in this particular row you have to look below the column 4. This is the column 4, and then you have to add up this number which appears under the column 9 in the mean difference table in the same row. The row will have to be the same. This is going to be the row for us. So 4449, what we are going to do, 44, and then 4 of 44 is 2780. Is it here? Right? And then we'll add up whatever digit is there under the 9 mean difference column in the same row, and the digit here is 6. So basically what we'll do, we'll add 278026 and we'll get 2786, right? Then once we have got 2786, what we are going to do next, I'll give you a rough calculation what we are going to do next. 2786, well, this is the anti-log value, so that is fine, but what about the characteristic? How are we going to make utilization of that? So characteristic was 5, you add 1 to 5, it becomes 6, and since this characteristic was positive, it was plus, you will have to do what? You will have to insert a decimal after 6 digits from the left. However, there are only 4 digits from the left here. So what will I do? I'll put in a 0 here, put in another 0 here, and then I'll put a decimal. So this becomes 278600. Is this understood? Right? Don't make silly mistakes. Some of the students, I find, they make this mistake. They look, rather than looking for 4 in the row of 44, they would start looking for 4 in the row of 54. This is not to be done. That is why I said in the first step, separate the characteristic from the mantissa, and then only worry about the mantissa to find out the value from the log table, anti-log table, right? Now let us have a look at the other questions that are there. Anti-log of 1.4449. What is the value of anti-log of 1.4449? Now you look at the mantissa. It is same as the mantissa in the above question, above example, 5.4449. So the value would also be the same, the anti-log value that we'll find from this table, and that is the case here. Here also we find 2786, but since the characteristic here was 1, and when you add 1 to 1 it becomes 2, which means you'll have to insert the decimal after 2 digits from the left. So this time I have inserted the decimal here after 2 digits from the left. So this is the direction in which you will be moving, not from the right hand. Don't make this mistake. Now let us discuss one more case. Anti-log of 0.4449. You will see that since the mantissa is the same again, we'll put the same value. However, where to put the decimal, again that will depend on the characteristic value. Have a look at the characteristic value 0, add 1 becomes 1, which means after one digit you will have to insert the decimal after one digit from the left. So you are inserting the decimal after one digit, after 2 from the left, right? In this direction you have moved. Okay, one more question. Antilog 1 bar 0.4491. 1 bar means minus 1. So the characteristic here is minus. It's a negative value. So the value for characteristic is a negative 1. And that is why this time you'll have to have a slight change in the methodology. You will still find out the same thing. You have 0.449. There's a mistake here. Actually, it is basically 0.4449. Should I make this correction here? Let me make this correction. In the meanwhile, can you do the calculation on your own? Can you find out the antilog value of this particular number that we are discussing? 1 bar 0.449. In fact, it is actually 1 bar 0.4449. So actually, this is what I meant here, and actually I've forgotten to mention 1.4, and that was why this happened. So can you tell me what will be the value of antilog 1 bar 0.4449? Have a look at the mantissa portion. It's still the same as the one used in the above example, same as in the examples here. Oh, why did okay, right? So this is again minus 0.449, which means this portion 2786 would remain the same. However, now I have to look at the characteristic value, and the characteristic value is minus 1, and I add 1 to minus 1. Minus 1 plus 1 becomes 0. So how many zeros would be there between the decimal and the first non-zero digit? This will be the first non-zero digit in my answer, right? And how many zeros would be there? 0 zeros, because minus 1 plus 1 is 0. So 0 zeros between decimal and the first non-zero digit. So I have not 0 zeros means no zeros at all. So I have not put in any 0. So now the answer is 0.2786. Again, in this case, 2 bar 0.44. Again, this is 0.4449. Excuse me for this mistake again. Kindly start doing this calculation on your own. You know that the antilog value per 0.4449 is 2786. Can you do this calculation on your own? In the meanwhile, I'll make some corrections here. Right, I've done this now. So minus 2.4449, what is going to be the antilog value for this particular number? Have a look. Okay, so basically, since the mantissa is the same, so you have the antilog value also as the same. However, the only thing which will have to be changed now is going to be the placement of the decimal, position of the decimal. Now this is minus 1. Minus 1 plus 0 is 0, and that was why this one's 0.2786. We inserted 0 or no zeros between decimal and the first non-zero digit. But in this case, the value of the characteristic is minus 2. So minus 2 plus 1 becomes minus 1. And now what you'll have to do is you have to find out the mod of this value. I told you this particular thing. So this has to be actually in the mod, and this would mean 1. So after the decimal, you have to insert how many zeros? 1 0. Is this understood? Why? Because minus 2 plus 1 is minus 1. So the number of zeros would be mod minus 1. Mod minus 1 would be 1. So number of zeros between decimal and the first non-zero digit would be 1. And this can be seen here, shown here, right? So friends, this is all in this particular topic in the logarithms. Now you know how to calculate the logarithm of a number using the log table, how to calculate the anti-logarithm of a number using the log table. However, I would want to tell you that you may or may not always be given a logarithm table, and in such cases you are expected to know 3 values basically. This is log 10 base 2, likewise 3, and likewise 10. So basically you should know the values of log 10 base 2, log 10 base 3 and log 10 base 10. Please understand the logarithm table which I have shown here, or the log table which I have shown in the earlier session, they all are prepared with 10 as the base, so you don't need to worry about the base here. So log 2 you should remember, you will have to go and look at the logarithm table, log 3 and log 10, because these values might come in very handy, and it is expected that you know them because not always would the logarithm table be provided to you. So log 2, for example, I know log 2 is 0.3010, and if I know that particular piece of information, I can attempt many questions despite not being given a logarithm table or an anti-logarithm table. This is okay. So remember log 2, log 3 and log 10. Log 10 would be 1, and I'm talking about the log 10 with 10 as its base. So log 10 base 10 would be 1, log 10 base 2 is 0.3010. Likewise, you have to find out log 10 base 3. This is fine. So do remember these values. They might come in handy while appearing in the exams. Okay, thank you very much for your time. We will be moving on to the next session very soon, and there we'll be talking about the operations of the various properties of the log and the anti-log values, and we'll be doing some operations related to logarithms. Fine, thank you very much.